This is Professor Pelton. This is part 1 of chapter 3, section 5, doing transformation. So I put the transformation list at the beginning of the section. So essentially, the transformations, if you add or subtract a number to a function, whether it's in the inside or the outside, it'll shift it or translate it up, down, left, and right. Also, if you negate the inside or the outside, if you negate the inside or the outside of a function, it will reflect it over its corresponding axes. Okay. Notice that the negative on the outside affects the y, so it'll flip over the x-axis. The negative on the inside affects the x, so therefore it goes over the x-axis. And accordingly, if you do something on the inside, it affects the x value. If you do something on the outside, it affects the y value. And then lastly, multiplying by a factor will either stretch or shrink. So multiplying by a factor on the outside stretches or shrinks y, and multiplying by a factor on the inside will stretch or shrink the x values. This is your basic table of all the transformations for any function. And then the order of functions, which is essentially the order of operations, is here, because the horizontal translation is parentheses, and it ends with vertical translation, which is adding and subtracting. So these are the 4 levels of order of operations, just put in terms of transformations. If you have multiple to do, you have to follow this order. Okay, so basically this is your list of transformations. So first is a translation, which is when you move it up, down, left, and right, or vertically or horizontally. Okay, so that's adding and subtracting to the outside for vertical, adding and subtracting to the inside for horizontally. So reflecting is when you change them over a line of symmetry. Okay, typically that's just going to be the axis itself. And scaling is going to be stretching or shrinking, which when you're multiplying by a factor greater than 1, or if it's shrinking, you're between 0 and 1 essentially. So 2/3, for example, or 0.2, anything like that would be fine. There are other synonyms that they use besides stretching and shrinking. Those will all go with, but they vary from book to book, the synonyms that they use. So there's a variety of ways you can do these next ones. So one way is to use a graphing calculator. Okay, I'll go through it with mine. You can also just look back at the table up here and decide what the transformation is. You can also use websites such as Desmos and Wolfram Alpha to get what the transformations look like, because any of those websites, whether it's Desmos or Wolfram Alpha, will show you what the graph looks like. All right, so say I have an absolute value of x plus 2. So if I add 2 to the inside, what does that do according to my table? Well, if I go to my table, adding 2 to the inside is going to move me left. Okay. So adding 2 to the inside moves you left. Let's look at the calculator. Okay, where's the absolute value? And here's the one adding 2. I'm sorry, and this is the one adding 2. So clearly it moved left 2. All right. So it's going to translate left 2. Okay, so if I minus 1 to the outside, it's going to translate down 1. And how do I know that? What's on the outside, so it affects y. So that's how I know. Also, if I go back to my table up here, subtracting to the outside moves you down. And also, if I look at my calculator, okay, this is the standard function, and this is the minus 1. Clearly, it went down 1 spot from 0 to 1, and all the way down, it went down 1. Okay, so lastly, what about 3/2 in the front? That's multiplying on the outside. If there were parentheses, which there are not, it would be on the inside, but there's no grouping symbol, so it's on the outside. So let's look up here. So multiplying by the outside is either a stretch or a shrink, but since it's greater than 1, it's a stretch vertically. Okay, so multiplying by 3/2 is going to change the y value. So it's a stretch vertically. by a factor of 3/2. All right, pause the video. You either use the websites, the table, or your calculator to determine what the following transformations do. Okay, so the following is a 0.2 on the outside, so it only shrinks vertically because it's on the outside. There's no grouping symbols to put on the inside, so it's not x, it's changing. Shrink by a factor of 0.2 or 1/5, whichever one to put. Okay, so we have a -1 on the outside. Multiplying by 1 doesn't change anything, right? 1 times anything itself. However, the negative does make a difference. That's a reflection if you look back at the list. So that's a reflection on the x-axis. You're going to flip over the x-axis essentially. So that's your line of symmetry, because if it was in the inside, it would affect x, but it's on the outside, it affects y. So if you change your y value, right, if you change your y value, okay, this is your y-axis right here. If you change your y value, you went from positive to negative, negative to positive, right? So essentially you went over the x-axis if you change your y value. All right, so lastly, adding 2 to the outside, that is a translation up 2. Okay, since it's on the outside, it affects y. You're just going up 2. You can check that yourself with the calculator. Okay, let's look at these down here. And there are multiple of them in this case. There's an order to them, but we're just describing what they do. So the 2 is a translation up 2. It's translation up. Okay, the 1/4 is a vertical shrink. Okay, because again, there is no grouping symbols, there's no insides, everything just affects y at this point. And then we have a negative here, which is a reflection on the x-axis, right? Because if it's on the outside, it changes y. If you change y, you went over your x-axis. Okay, so the next one does have a grouping symbol, so you do have an inside, so it does affect the x, right? So the -2 is a translation right, okay, because it's always counterintuitive on the inside. Whenever you have a grouping symbol, it's the opposite of what you think. So minus is right and plus is left. Okay, so the -1 is a translation down. Okay, and the 3 is on the outside, so that affects y. So that's a vertical stretch. Okay, pause the video, try to do problems for yourself. Okay, so it does have a grouping symbol, right? Those are absolute values. So the +2 that's in the inside, okay, is a translation left. It's always counterintuitive on the inside. Okay, and the -3 is a translation down. The 1 does nothing. 1 times anything doesn't change anything. However, the negative, right, that is a reflection on the x-axis. Okay, because it's on the outside, it's changing the y value. Okay, last few. So the -1 is a translation to the right, because it's on the inside of the grouping symbol. So it's counterintuitive what you think, and it must change the x value. The 2 is on the outside, so that affects y. So that is a translation up. And the 3/2 is on the outside, so that affects y also. If it was on the inside, it would affect x. So that's a vertical stretch. Okay, and what you'll notice about each one of these, they only affect x, so they only affect y. They do not affect both, each item that's in the function. Okay, so one more page here. Okay, so let's look at vertical shifts more formally. So what you'll notice here is I'm using C as my letter, but it really can be any letter you want. Adding and subtracting to the outside is going to affect Y, which will transit you up and down. You can check this accordingly by doing tables. Okay, so let's do just a basic absolute value of X. So X and Y. Okay, let's say I do -2, -1, 0, 1, 2. Well, the absolute value, whoops, that's too close together. The absolute value of -2 is obviously 2. That's 1, that's 0, that's 1, that's 2, right? Because the absolute value of -1 is 1, the absolute value is 0, the absolute value of 1, and the absolute value of 2. Okay, so this is the table for this, the absolute value. So at -2, I'm at 2. At -1, I'm at 1. At 0, I'm at 0. 1, I'm at 1. And then 2, I'm at 2. So it's the graph that I thought. It's a V, because absolute value, right, spelled with a V. So if I minus 4, it should just move all my values down by 4, right? So what should happen is I should go down 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And now I get my new function down there. I probably should have changed colors, to be honest. Right? Let's change colors just for argument's sakes here. I'll make this one red. And it goes on forever, of course. Okay, so what you'll notice about these coordinates, okay, it only affects the y value. So now I have 0, -4, but these don't change. -2, -1, 1, and 2. The x values don't change. They just go down, don't they? So at 1, I'm really at -3. At 2, I'm really at -2. Okay, at -1, I'm at -3. And at -2, I'm at -2. So the only thing that really changed is the y value and the y value only. All right, pause the video, try the student problem for yourself. Okay, so we're going to try the square root function first. So if I do the square root of x graph, oops, got a pinwheel of death going here. Not quite sure why. Oh, there it goes. Now I have to erase a little extra mark it made. Okay, let's try that again. All right, so I'll make an x and y table. So I can't pick negative numbers, right? I can't pick -1, but I can pick 0. I can pick, I don't know, 1 works, 4 works, 9 works, right? Because the square root of a negative is undefined, right? It's actually a negative. It'll be I, but we don't care about that as far as a real graph. So we're just going to ignore that. So the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3, right? Because the square root of 0, square root of 1, square root of 4, and the square root of 9, right? Okay, so we're at 0, 0. We're at 1, 1. We're at 1, 2, 3, 4, 2. And we're at 9, 3. So that is our standard graph. Okay, so if we have a +3 on the outside, that's going to move us up 3, correct? So that's going to go 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, right? So essentially, if you look at those values as far as the table goes, right, that does not affect the x whatsoever. 0, 1, 4, 9. I could have picked 2 and 3 and 5 and 6 on my table, but I want things that I can actually do easily. Okay, so if I just add 3 to those, I get 3, I get 4, I get 6, and I get 7 essentially. Wait a minute. That's 5. I'm sorry. This 2 plus 3 is 5. This one's 6. I didn't add. I'm looking at the wrong numbers. I apologize. Right, because I have to add to that. I was looking at the wrong numbers. Okay. All right, so let's say I want to write a function g that has the following transformation, translate 3 units down. So basically I want to write is f of x minus 3. That's what I really want, right? Because I'm going to 3 units down. So that gives me 2x plus 1 minus 3, right? So I need to call this something else. So I'm calling it g of x because that's what the question is saying. But it doesn't really matter what I call it as long as I don't call it the original function. So what I really have here is 2x minus 2 is the new function as it's been translated down. So that's the original, that's the new function. All right, pause the video, try the student problem. Okay, so for the student problem, we're going to translate 3 units up. So that's h of x plus 3. So I get 5x plus 1 minus 2. And then we're going to add 3. So my new function, let's go to red here, is we're calling it p of x, I guess. P of x is 5x plus 1, and then it'll be plus 1, because minus 2 plus 3 once I distribute. Okay, that is our new function. You can check there itself with the graphing calculator, or you can just go to Desmos and type it in. That is the end of part 1.